Algebra 2, we are going to be covering lesson 60. It's on the probability of mutually exclusive and independent events. And that sounds much harder than it actually is. So we're looking at probability. So we're going to do a couple examples. So let's say that I have 10 marbles. Let's say I have 5 that are red, and I have 4 that are blue, and I have 1 that is green. Okay, and let's say these marbles are also numbered. So let's say my red are numbered 1 through 5, and the blue are numbered 6 through 9, meaning one has 6, one has 7 on it, one has 8, one has 9, and the green one is labeled number 10. So what is the probability if I reach into this bag of marbles that I select a blue or an even number? So that word or changes how we calculate probability. So I know that when I see the word or, I'm going to add, and if I see the word and, I'm going to multiply. So in this case, I see or, so I know I'm adding. Now, I'm going to start with blue. So how many blue marbles are there? Well, there are 4. So I have 4 blue. When we do probability, the bottom should always be the total. So I have 10 marbles, so 4 out of 10. Okay, so this is how many blue there are. Or, so add even numbers. Okay, so my even numbers, right, are 2, 4, 6, 8, and 10, right? From numbers 1 through 10, those are the even numbers. And I'm going to count how many there are. 1, 2, 3, 4, 5. There are 5 out of 10. So that's how many even numbers. Now, are there any blue that are also even? So I would say, so there is a term for this. Because I have blue marbles that are also even, these are overlapping events. Because there are blue even numbers. So I have to subtract the number of marbles that are both blue and even. And I wrote them up here. 6 is blue and it's also even. And 8 is blue and also even. So there are 2 out of the 10 marbles that are both blue and even. So my final answer, we're simply going to add and subtract these. So 4 plus 5 is 9. 9 minus 2 is 7. So I end up with 7 over 10. Okay? Now, let's say I asked you, what is the probability that I get a red marble or a 2-digit number? Okay, so same marbles. So how many red? There are 5 red out of 10 total marbles. Or means I'm adding. How many 2-digit numbers do I have? Well, from the numbers 1 through 10, only one of them has 2 digits. Now, are there any 2-digit? This 2-digit number is green. So there are no overlapping events. So this would be an example of mutually exclusive because the red are not 2-digit. So there is nothing that's in both categories. So I would simply add them together. That would give me 6 over 10, but we should reduce probability, so that's 3 out of 5. All right, so let's jump into our lesson practice starting on page 430, and I'm going to start with part A. And part A asks us, a number cube is rolled once. Are the events that the number rolled is odd, so this one says, and the number rolled is greater than 5. So is that inclusive or mutually exclusive. So another word for overlapping is inclusive. And think of inclusive as like it's included in both events. So on a die, there's numbers 1, 2, 3, 4, 5, 6. These are odd, right? And greater than 5. So numbers that are odd are 1, 3, and 5. Numbers greater than 5 are 6. There is nothing that is in both. So this would be mutually exclusive because 6, like none of these numbers are in both categories. So this is mutually exclusive. Part B. A number cube is rolled once. So I still have a number cube. I still have a die or number cube. What is if you have a number rolled is even and divisible by 3. So I'm going to put divided by 3. So let's list our numbers. I'm not sure why it's a slightly blurry today. I don't know if it's my camera. Sorry, I'm wiping my camera. Interesting. All right, so even. Let's list our even numbers. 2, 4, 6. And let's list numbers that are divisible by 3. Well, 3 and 6. 3 divided by 3 is 1. 6 divided by 3 is 2. Notice that I have a number that appears in both. So this would be inclusive. Part C. So a jar contains 10 green and it contains 10 orange. What's the probability? Oh, and the green are numbered 1 through 5 and 11 through 15. The orange are labeled numbers 6 through 10 and 16 through 20. And this asks, what's the probability, let me see how they word it, that the marble drawn from the jar is odd or green? So let's do a little investigating. I'm sorry that the screen is a little blurry. So let's odd. I have to find all the odd numbers. So my green odd numbers would be 1, 3, 5, right? 1 through 5. 11 through 15, 11, 13, 15. Odd here would be 7, 9, 17, and 19. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. There are a total of 20 marbles, so 20. Plus green. I have 10 green marbles, right? But I have to subtract all the marbles that are both green and odd. And you wrote them up here. There are 1, 2, 3, 4, 5, 6 that are both green and odd. So 10 plus 10 is 20. 20 minus 6, I got 14 over 20, or 7 out of 10. Okay, moving on to part D. Part D is on the next page. Sorry, I have to turn the page, and my book is not cooperating. A jar contains the same marbles, so same marbles, but this time it asks, what's the probability that the marble is orange or less than 6? So I like to use shorthand, so that's where you're getting that. So I remember that there are 10 out of 20 plus less than 6. So remember my orange marbles. Oh, less than 6. There are green that were numbered 1 through 5, and those are the only numbers less than 6. So 1, 2, 3, 4. So 5 out of 20. Now, are there any green that are also orange and less than 6? No, The numbers less than 6 are green. They're not orange. So nothing overlaps here, so you get 15 out of 20. Or if you divide both of those by 5, you get 3/4. All right. Next one, they part E and F, they were wanting just us to list whether they're independent or dependent. And in part E, you're flipping a coin and then rolling a dice. Those don't affect each other, so you would say that they're independent. Part F, if I or remove a tile, but I don't replace it, that will affect the outcome, so those are dependent. So I'm actually going to do a different example so you can see. So example number 2. If I have 9 white blocks and I have 7 green blocks, and I say if I draw, and you're going to draw 2 blocks, what's the probability the first is white and the second is green? So notice my vocabulary changed. I'm no longer asking about or. So I'm going to be multiplying my probabilities. So let's start with the white. There are 9 white. The bottom should always be the total. There's a total of 16. And how many are green? I'm sorry. And I am with replacement. Now, with replacement means that when I take this first block out, I'm going to replace it. I'm going to put it back in the bag or back in the box. And so there are still 16 blocks when I go to select a green. So from here, there's nothing I can reduce, so I would get 63 over 256. Now, let's say I asked you the probability that I get the first one is a white block and the second one is white without replacement. Without replacement means you are going to keep that first block. So the probability that the first one I grab is white is the same, 9 over 16, and means I'm multiplying. But if I kept this one block, I didn't take out all 9. Remember, I'm only drawing 2 blocks. So now I only have 8 that are white left over, and now there's only 15 in the bag. So I can reduce this. 8 over 16 is 1 over 2. 9 over 15 is 3 over 5, so I end up with 3 over 10. So we are going to use that example to complete the last 2, part G. G says that I have 12 marbles and I have 7 blocks. An object is drawn from the jar and then replaced. Find the probability that in 3 draws I draw a marble, a block, and a marble, but I said they are replaced. Okay, so the probability of the first one is a marble would be 12 out of 19, because if you add these together, you have 19 total. Times, because I'm drawing 3, okay, 3 blocks, so n, then I'm going to draw the block. Now, they will have to say the word or, so if you don't see the word or anywhere, you're multiplying. And then how many are the probability that the last one is a marble. Notice my numbers don't change because each time whatever you draw, you're putting back. So I got 1,008 over 6,859, and then I made that into a decimal. Last one says that there approximately 48.8% of live births are females. What's the probability that you would give birth to 3 daughters followed by 1 son? Well, 48.8% are out of 100. So that would be the first daughter, the second daughter, the third daughter, And then 100 minus 48.8 would give you the probability of a little girl. And so I believe you get 100 minus 48.8. I got 51.2 out of 100. So this is daughter, 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 son. And so you get a kind of crazy, really large number, but divide it to make a decimal. And the probability of that happening is about 6%. So for homework for this lesson, you're going to skip numbers 6, 7. Nope, I'm sorry. I was looking at an old list. You're going to skip, my apologies, number 2, 10, 11, 14, and 16. Thank you.